Welcome to CRANN's second Thesis in 3, where we have PhD students from a number of different groups presenting their work in 3 slides in just 3 minutes.
The title of my presentation today is Making Vaccines with Particles. So the vaccines are one of the most important discoveries in the modern medicine. They protect us against many diseases by inducing strong immune response.
Graphene is a super material. The reasons are that it's a very strong material, and it's 130 times stronger than the strongest material and it's 130 times stronger than steel.
We take a material which has sheets of atoms, sonicate, and we're left with just these 2-dimensional nanosheets. And when we get down here, the properties are incredible.
It's really difficult to communicate science to a lay audience. I know that firsthand, and I think everybody did a great job of taking really technical concepts and boiling them down to stuff that's very easy for people to digest. I certainly learned loads this evening, and I think it's a great exercise for PhD students to do that with their projects.
In the future, we'd like to move towards something like this, where we take a small sample of your blood. It's cheap, it's so easy a monkey could do it. And basically the aim of my PhD then is how we go from the situation on the left to the situation on the right.
Our research interest is not only in observing nanomaterials, but also in modifying their structure and the properties of the nanoscale.
So what I'm doing in my PhD is exploiting and developing a new manufacturing technique. Because the idea is that I would like to create an array, a pattern object of this silver ball to improve the properties of this material.
It's such a valuable skill to be able to kind of present like that, you know, in 3 minutes.
When we think of these devices, what comes into mind is that they store a remarkably large amount of information in a very small space. For example, this stores 16 gigs of information.
I thought it was a very engaging, very stimulating evening, and there's such a variety of projects which I thought was fantastic.
What happened here is there was a plane flying between LA and Hawaii when all of a sudden the top of the plane ripped right off. Now, I'm sure it was terrifying for everyone on board, but us being scientists, we're going to just focus in on the mechanics.
So when we tested the oligomers and fibers on these cell lines, we saw that they killed them at really low concentrations. They're very toxic to the cells, and they also kill both the tumour and the healthy cell exactly the same, so really toxic to the cell, which was quite surprising.
The enthusiasm of the group and participating is really wonderful to see. The projects themselves I thought were very nice and varied across a variety of different areas, a lot of enthusiasm in the students, and generally I think some really good projects. The 35 Euro prize goes to Arlene O'Neill.
I thoroughly enjoyed it because I love to take it down to the very basic level and explain what we do and try really reach out to as many people as we possibly can.
Second prize goes to Roseanne Riley.
I'd say it was the worst prize ever because you win and you get sent to the Mansion House to perform in front of how many people exactly? Yeah, exactly. I was like, wow, that'd be terrifying, and that's when my name was called out.
And the first prize goes to Jason Jensen.
Yeah, I'm delighted. I'm really surprised, but it seemed to go well and everyone seemed to like it, so happy enough. I'm 3 years in now and I've already developed a device, and now I'm just working on getting the whole nanoparticle side of it to work, but it's showing promising results so far, so within 1 year hopefully I'll be finished.